Welcome to the Agrahead. Carnes Crossroads is a new home community with a farm-to-table lifestyle. Just outside of Charleston, here, community is defined by gathering together and our deep connection to nature.
Learn more at carnescrossroads.com.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 26, Episode 95, for broadcast on the 9th of August 2023. Coming up on SpaceTime, astronomers shed new light on mysterious fast radio bursts, a European satellite crashes back to Earth, and a giant solar eruption so powerful it was felt on the Earth, the Moon, and Mars. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Almost 15 years after the discovery of fast radio bursts, those ephemeral millisecond-long deep space cosmic explosions of electromagnetic radiation, astronomers worldwide have been combing the universe to uncover clues about how and why they happen. Nearly all fast radio bursts identified so far have originated from deep space, well outside our Milky Way galaxy. That was at least until April 2020, when the first galactic fast radio burst, designated FRB 2020-0428, was detected. The event was produced by a magnetar, SGR J1935 plus 2154. Magnetars are a type of neutron star with an incredibly powerful magnetic field. The groundbreaking discovery led many astronomers to believe that fast radio bursts identified at cosmological distances were probably also produced by magnetars. However, the smoking gun proving such a scenario, that is the rotational period, due to the spin of the magnetar, has so far escaped detection. Now, new research into SGR J1935 plus 2154 sheds new light on this curious discrepancy. A report in the journal Science Advances, looking at the continued monitoring of the magnetar following the April 2020 fast radio burst and the discovery of another cosmological phenomenon known as a radio pulsar phase 5 months later, found that the two events originated from different regions within the same magnetar. That suggests different origins. The observations were made by FAST, the 500-metre aperture spherical radar telescope in China. It detected 795 pulses in 16.5 hours over 13 days from the same source. The study's lead author, Weiwei Zhu from the National Astronomical Observatory of China, says these pulses show different observational properties from the bursts. The dichotomy in emission modes from the region of the magnetosphere helps astronomers understand how and where fast radio bursts and related phenomenon can occur. Radio pulses are cosmic electromagnetic explosions similar to fast radio bursts, but typically emit a brightness roughly 10 orders of magnitude less than a fast radio burst. Now, these pulses are normally observed not in magnetars, but in other rotating neutron stars known as pulsars. And the thing is, magnetars do not emit radio pulses most of the time, probably due to their extremely strong magnetic fields. But some of them, such as SGR J1935 plus 2154, become temporary radio pulsars after some bursting activities. Another trait that makes bursts and pulses very different are their emission phases. That is, the time window where radio emissions are emitted in each period of emission. Like the pulses in radio pulsars, the magnetar pulses are emitted within a narrow phase window within the period. Now, this is the well-known lighthouse effect, namely an emission beam sweeping through a line of sight once a period and only during a short interval time within each period. From here on Earth, we observe these as a pulsed radio emission. But the 2020 fast radio burst, as well as several later less energetic bursts, were all emitted in random phases, not within the pulse window identified from the pulsar phase. Now, this strongly suggests that the pulses and the bursts originate from two different locations within the magnetized magnetosphere, and that suggests the possibility at least of different emission mechanisms between pulses and bursts. Such detailed observations of a galactic fast radio burst source at least shed some new light on these mysterious bursts, whether they're erupting at galactic or cosmic distances. Many sources of cosmological fast radio bursts, those occurring outside our galaxy, have been observed to repeat. In some cases, astronomers have detected thousands of repeated bursts from a few sources. Deep searches for periodicity have been carried out using bursts, but no period has been discovered so far. And this therefore casts doubt on the popular idea that repeating fast radio bursts are powered by magnetars. The discovery that bursts tend to be generated in random phases provides a natural interpretation to the non-detection of periodicity from repeating fast radio bursts. And also, for unknown reasons, bursts tend to be emitted in all directions from a magnetar, making it impossible to identify periods from fast radio burst sources. It's the problem that isn't going away, and that in itself is fascinating. This is SpaceTime. Still to come, a European satellite crashes back to Earth in an historic assisted re-entry, and the Sun erupts in a giant coronal mass ejection felt not just on Earth, but also the Moon and Mars. All that and more still to come on SpaceTime. The European Space Agency's Aeolus spacecraft has successfully burnt up during atmospheric re-entry over Antarctica. The event was the final chapter in a 4-day-long assisted re-entry operation by ESA, which gradually lowered the spacecraft's orbit in a controlled manner. Today, satellites are designed so as to minimize the risk of causing damage during their return to Earth by being guided down towards Point Nemo, a location in the southern Pacific Ocean that's the furthest place on Earth from any land, and also away from airline and shipping routes. But Aeolus was designed in the late 1990s, before new space regulations came into force. The 1,360-kilogram Aeolus satellite, named after the guardian of wind in Greek mythology, was launched aboard a Vega rocket from the Kourou spaceport in French Guiana back on August 22, 2018, on what was meant to be a 3-year mission to study the Earth's atmosphere from a 320-kilometre high orbit. The probe measured Earth's global wind patterns, providing vertical profiles of horizontal wind speeds and backscatter information on clouds and aerosols, something that had never been done in detail from space before. Aeolus also undertook a series of end-of-life experiments to help improve future LiDAR missions in space. The data will help scientists improve their forecasts for weather systems and their models of climate change. Aeolus operated for nearly 4.5 years, that's some 18 months longer than its planned life expectancy. But the spacecraft eventually began running low on fuel reserves, and rather than just let the Earth's atmosphere drag Aeolus down in an uncontrolled chaotic re-entry, mission managers decided to undertake a controlled descent. The deorbit campaign was designed to ensure Aeolus burnt up over an unpopulated area. You see, around 20% of a spacecraft's mass, mostly titanium and stainless steel structural components and equipment, survive the fiery trip through the atmosphere, with enough charred wreckage left to reach the planet's surface. About 100 tons of space junk fall on the Earth each year, with large objects re-entering the atmosphere about once a week. Aeolus began dropping from orbit on June the 19th, and mission managers began accelerating the process 5 weeks later on July the 24th, when they initiated 2 engine burns lasting a total of 37.5 minutes, designed to lower the spacecraft's altitude by around 30 kilometers to a height of some 250 kilometers. Then on July the 27th, Aeolus performed 4 planned engine lowering maneuvers, with a final 5th burn the next day, setting the stage for a controlled re-entry 5 hours later. This report from ESA TV.
Aeolus launched into orbit in August 2018 from Europe's spaceport in French Guiana and became the first satellite to measure global winds from space using a laser. Named after Aeolus, the keeper of the winds in Greek mythology, the satellite carries one of the most sophisticated instruments ever to be put into orbit. The Aladdin instrument beamed down 7 billion pulses of UV light to profile Earth's wind. Although designed as a 3-year mission, Aeolus has exceeded not only its predicted lifetime, but also all expectations. Over the past 5 years, its data has been used in major weather forecasting services worldwide. It has tracked the Hunga Tonga volcanic plume, improved the forecasting of hurricanes, followed the huge Saharan dust plume, shed a light on Earth's polar vortex, and filled the gap in weather forecasts when airplanes were grounded during COVID lockdowns. Altogether, it has brought 3.5 billion euros worth of economic benefits over its lifetime, and is hailed as one of the most successful missions ever built and flown by ESA. Today, satellite missions are designed according to regulations that require them to either burn up entirely or undergo a controlled re-entry at the end of their lives in orbit. This first attempt at an assisted re-entry sets a new precedent for re-entering active satellites that didn't fall under these regulations when designed. With Aeolus, ESA is paving the way for safe re-entries and responsible space. Given the rapidly increasing amount of space traffic, protecting our precious but ever-crowded orbits has never been more important.
This is SpaceTime. Still to come, a massive coronal mass ejection rocks not only the Earth, but also the Moon and Mars. And later in the science report, a new study has shown that the average Australian lifespan has increased by around 6 years. All that and more still to come on SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Hello, I'm Ryan.
And I'm Catherine.
We're part of the BlendJet team.
And husband and wife. If you're one of the 5 million people who use a BlendJet portable blender, thank you.
A few years ago, I had a freak accident and almost died. Daily smoothies have helped me recover.
We created BlendJet to help people live healthier lives by making it easy to enjoy perfectly blended smoothies and protein shakes anytime, anywhere.
The BlendJet 2 portable blender is powerful, USB rechargeable, cleans itself, and comes in over 30 colors.
Get yours now on blendjet.com.
A coronal mass ejection, a giant solar eruption detected simultaneously at the Earth, the Moon and Mars, has emphasized the need to prepare human deep space missions for the dangers of radiation. The coronal mass ejection erupted on the Sun on October the 28th, 2021, and it was seen over such a wide area of the solar system that Mars and Earth, while on opposite sides of the Sun at the time, around 250 million kilometers apart, still both received an influx of energetic particles. Coronal mass ejections are powerful blasts of energy and material from the Sun's surface. They're caused by the snapping of magnetic field lines emerging from the Sun through sunspots, triggering solar flares. The explosions carry ionized solar material, including protons, electrons, and helium nuclei, as well as magnetic field and blasts of photons bursting out at far higher speeds and higher amounts than the usual background streams of material flowing out from the Sun in the solar wind. When these coronal mass ejections reach Earth, they generate spectacular auroral displays, the northern and southern lights, the aurora borealis and aurora australis. But the high-speed particles they carry can also damage spacecraft in orbit. It affects navigation and communication systems, and can even trigger power blackouts on the Earth's surface by overloading power lines and transformers. And they also increase radiation levels for astronauts and people in high-altitude aircraft. A report in the journal Geographical Research Letters claims the October 28, 2021 event was the first time that a coronal mass ejection was measured simultaneously on the surfaces of the Earth, Moon and Mars. It was a great opportunity to observe the evolution of such an event over a wide area of space. The blast was detected by an international fleet of spacecraft, including the European Space Agency's ExoMars Trace Gas Orbiter, NASA's Mars Curiosity rover, China's Chang'e 4 moon lander, NASA's Lunar Reconnaissance Orbiter, and Germany's Eucropies Earth-orbiting spacecraft. The simultaneous measurements on different worlds using different instruments will help improve science's knowledge of the impact of solar storms and space weather events, and how a planet's magnetic field and atmosphere can help protect astronauts against them. What made this event so special is that it was an example of a rare ground-level enhancement. During these events, the particles from the Sun are so energetic, they pass right through the magnetic bubble that surrounds the Earth and protects the planet from less energetic outbursts. But they're not that common. This, for example, was only the third ground-level enhancement since records began in the 1940s, and none have been recorded since this event. Now, as the Moon and Mars don't generate their own magnetic fields, particles from the Sun can easily reach their surfaces and easily interact with the soil to generate secondary radiation. But Mars at least does have a thin atmosphere, only 1/99th that of Earth, but enough to stop most of the lower energy solar particles, and it can slow down the high energy ones as well. The Moon, on the other hand, has no atmosphere, just a very thin exosphere of rarefied particles. But with the Moon and Mars the focus of future human exploration, it's extremely important to understand these solar events and their potential impact on the human body. For astronauts, it means the risk of radiation sickness. A radiation dose above 700 milligray, that's the unit for absorption of radiation, may induce radiation sickness through the destruction of bone marrow, resulting in symptoms such as infection and internal bleeding. If an astronaut receives more than 10 Gray, they're extremely unlikely to survive more than 2 weeks. There was one solar outburst in August of 1972 that was so powerful it would have irradiated any crew on the lunar surface at that time. But luckily it hit right between the Apollo 16 and 17 missions. By comparison, the event on October the 28th, 2021 was measured by NASA's Lunar Reconnaissance Orbiter at just 31 milligray. Calculations of past ground-level enhancement events shows that on average, one event every 5.5 years may have exceeded the safe dose level for the Moon if no radiation protection had been provided. Understanding these events, therefore, is crucial for future manned missions to the surface of the Moon and ultimately Mars. When scientists compare the measurements made by ExoMars and the Curiosity rover, the protection offered by Mars's atmosphere becomes clear. ExoMars measured 9 milligrays. That's 30 times more than the 0.3 milligray detected on the Martian surface. ESA's inner solar system missions, Solar Orbiter, SOHO and Bepi-Colombo, were also caught in the blast, providing even more vantage points to study the solar event. Currently, we live in a golden age of solar system physics. Radiation detectors aboard multiple planetary missions such as Bepi-Colombo on its way to Mercury and the JUICE mission cruising towards Jupiter add a much-needed coverage to the study, acceleration and propagation of solar energetic particles. During the manned Apollo missions to the Moon, astronauts often complained of seeing sudden ephemeral flashes of white light in their eyes. Following further investigation, NASA eventually concluded that these were cosmic ray particles. Shielding astronauts as they venture into deep space beyond the protection of Earth's magnetosphere is also an essential task for ESA and NASA. Dedicated instruments measure the radiation environment in space and are used to protect not just crucial spaceborne and ground-borne infrastructure, but also astronauts. If warned in time, crews aboard the International Space Station can retreat to their sleeping quarters or the galley where the walls are shielded against radiation. If they're on the Moon or Mars, they could either deploy special bodywear or shelter in caves, if there are any nearby. The Artemis program, which is sending astronauts to the Moon, includes a space station in lunar orbit called Gateway. Gateway will carry 3 suites of instruments especially designed to monitor the radiation environment around the Moon. There's ESA's European Radiation Sensor Array, or ESRA, NASA's Heliophysics Environmental and Radiation Measurement Experiment Suite, Hermes, and the joint ESA-JAXA Internal Dosimeter Array, or IDA. Together, these experiments will measure the radiation environment outside Gateway while also monitoring specific radiation doses inside as the space station orbits between 3,000 and 70,000 kilometers above the lunar surface. These measurements will be crucial to better understand the environment astronauts will be experiencing during interplanetary space missions. Space agencies are also looking into protective attire to help minimize the impact space radiation will have on the human body. 2 identical mannequins developed by the German aerospace agency DLR were passengers aboard the Artemis 1 test flight, which flew by the Moon during November and December in 2022. The mannequins, nicknamed Helga and Zohar, were modelled based on the female body and equipped with radiation sensors provided by DLR and NASA. Helga flew unprotected, but Zohar wore a newly developed radiation protection vest covering her torso. Researchers at DLR are currently comparing the 2 datasets. This is SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
And time now to take another brief look at some of the other stories making news in science this week with the Science Report. There's a new global warning from scientists today. It seems the strain of influenza A responsible for the 2009 H1N1 pandemic, PDM09, has been passed from humans to pigs at least 370 times since 2009, and once in pigs, the virus evolves into new strains, which can then jump back from pigs to humans again. The grim warning, reported in the journal PLOS Pathogens, looked at transmission data from PDM09 between 2009 and 2021 and took a close look at how the interspecies jumps have changed the DNA of the virus. They found that most of the human-to-pig jumps occurred when the PDM09 strain was most common in humans. But there were still 150 human-to-swine transmissions between 2018 and 2020 when human PDM09 infection rates dropped during the COVID-19 pandemic. Only a few of the 370 transmissions resulted in the virus evolving into new strains in pigs. But the authors say each new strain resulted in at least 5 people catching the virus from pigs. The authors warn that the DNA from these viruses suggests that existing flu vaccines would offer little protection. So, I guess once again, the pandemic clock is ticking. A bit of good news now, and a new statistical review has shown that over the last 30 years or so, the average Australian lifespan has increased by 6 years. However, the findings reported in the Lancet Medical Journal also show that non-communicable diseases such as cancer and heart disease still contribute to over 90% of all deaths. The study analysed the Australian data from the 2019 Global Burden of Disease study, which looked at trends of diseases and their risk factors between the years 1990 and 2019. In 2019, ischemic heart disease was the top cause of the year's loss of life, while 10 of the 25 top causes of years of life lost were due to cancers. Lower back pain was responsible for the most healthy life lost through disability in 2019, but there were also increases in the rankings of risks from falls, drug use, and anxiety disorders. The authors say the key challenges for Australia will be to keep an ageing population healthy, provide adequate resources to promote healthy lifestyles, especially in old age, and manage non-communicable diseases. Looking at the big picture, the latest United Nations data states the average Australian life expectancy now is 83.73 years. which breaks down to 85.56 years for females and 81.89 years for males. The people of Hong Kong now have the world's highest life expectancy at 85.83 years, followed by Monaco, Japan, Switzerland, Singapore, Italy, South Korea, Spain and Malta. Australia was in 10th place, and that was ahead of Sweden, Norway, Israel and France. New Zealand was in 18th place with an average life expectancy of 83.16 years, followed by Canada, Iceland, Ireland, the Netherlands, Austria, Finland, Belgium and Portugal. The United Kingdom came in 30th position with an average life expectancy of 82.31 years. That was followed by Germany, Denmark, Greece, Taiwan and Chile. If you're listening in the United States, well, you're in 47th position with an average life expectancy of 79.74 years. That's ahead of China, Turkey, Argentina, Hungary, Iran, Lebanon, Mexico, Jordan and Vietnam. Russia was in 100th position with an average life expectancy of 74.57 years, but that was ahead of Syria, India, Indonesia, Egypt, Afghanistan, Kenya and Niger. South Africa came in 178th position with an average life expectancy of 62.89 years. That was ahead of Zimbabwe, the Democratic Republic of Congo, Mali, Namibia, South Sudan, Nigeria and Chad in 201st place with an average life expectancy of 53.68 years, according to the United Nations. A new study has shown that even the earlier ChatGPT-3 version of the large AI language model can complete complex reasoning tasks and identify a reasonable solution for problems without direct training at a level that matches or even surpasses human participants. A report in the journal Nature Human Behavior tested the performance of ChatGPT-3 on solving new problems that it had not encountered before and then compared those results with human performances. This kind of problem-solving relies on a key mental tool known as analogical reasoning. That is, the ability to see similarities between unfamiliar problems and previously encountered ones in order to identify a reasonable solution. The authors found that ChatGPT-3 displayed a strong capacity for abstract pattern recognition, which matched or surpassed human test participants in most tests. A new sleeker iPhone is on its way. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
The latest rumors are that the bezel or the border around the screen is going to drop from 2.2 millimeters down to 1.5. Now, that doesn't sound like very much, but it just means that the visible area on the screen will be slightly larger. I mean, ultimately, Apple is said to want to get rid of any kind of visible notches or cameras on the screen at all, but they certainly, I don't think, will be able to do that this year because under-screen tech isn't good enough yet. And, of course, Apple does have that dynamic island, which more or less tries to hide the fact that there's a visible gap there that has the camera for the Face ID and the camera for the front-facing camera by inserting all sorts of other useful information like how long it's going to take for your Uber to turn up, or, you know, if you're talking to somebody, if you're listening to music or plugged in the power or got the AirPods, and it can show you this information in a way that doesn't detract or distract from anything else that's happening at the time. And this feature will appear on all 4 iPhones this year. That's the expectation, because with last year's phones, only the Pro versions had it, whereas the regular ones still had the notch. Now, the outside band should be titanium instead of stainless steel. Titanium is stronger than stainless steel, and it's 45% lighter. There's rumored to be an action button that's going to appear, which will get rid of the mute button, which is a physical up-down button. And this action button can be mute, but it can also be something that turns on the camera, or you could use it to do laps on a stopwatch. You could use it for lots of different things. It's meant to be programmable. Also, the volume and power buttons are meant to be solid state. Now, I've heard that's on, that's off. I'm not sure what it's going to be, but the expectation is that if it's on, it means yet more moving parts that are removed. But when you push the button, you'll feel vibration, much like with the trackpad on the Macs that have had this haptic feedback. And of course, you get things like more RAM, more memory, so it's got more thinking space and can keep more tabs open when you multitask. Obviously, better cameras, a USB-C port. But all of this is expected to see the price rise by $100 to $200 US, which would probably be about double that that in Australian dollars. And this might see the 1 terabyte iPhone 15 Pro Max be over $3,000 in Australia. We're yet to see if that's the case. We should also see things like better Wi-Fi 6E. So plenty of things are rumored, even an iPhone Pro Ultra of some sort, which would definitely have a bigger screen. And I'm not sure what other sort of features, but some people say that is going to be the version we see in 2024.
People want to find out more. Where will they go?
Just go to techadvice.life. I've got all the information there, including details about how Google Assistant is going to turn into like a chat GPT on your phone in a few months, a Norton Genie, an AI app that you can take photographs of messages and emails and websites, and it'll help you to tell you if it's a scam or not, and plenty more. So all the details that we speak about and more are at techadvice.life. The other big news this week is of a substance called LK99. This is a room temperature superconductor. Now, normally superconductors exist already, but they have to be cooled down to just a few degrees above true zero. Absolute zero, yeah. And so we have superconductors inside of MRI machines that if they can get this right, if they can get this to be something that's done at room temperature, then it means that we're not losing energy.
Problem is, it hasn't been peer-reviewed yet.
Absolutely, yeah. There's a lot of skepticism. Yeah, there's skepticism. People are saying it's a diamagnet of some sort, where it's more to do with magnetism rather than the superconductor effect. Look, there have been on Twitter in the past 24, 48 hours some people claiming that they've been able to replicate the results, but by no means is this a done deal that it is absolutely true.
That's Alex Zaharov-Reut from techadvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.